Now for this problem, what we're going to do is we're going to use the leading coefficient test to determine the end behavior of the given function. So once you start graphing higher ordered functions to the 4th, 5th, 6th, 10th degree, right, generally at the ends of the graph, like so for example, let's say our graph was maybe coming from this direction. In the middle, we're going to have some squigglies, and then it's going to go off to the end. And depending on what your power is, it's going to have all sorts of different turns and stuff here in the middle. That's not necessarily what we're concerned with. What we tend to see with a lot of higher ordered graphs is ignoring the center here. Just looking at what happens at the end of the graph, we see a lot of similarities. And, there's some things that we can just determine and know by taking a look at the equation. So that's kind of what this problem is dealing with. It's just taking a look at an equation and being able to tell what is going on at the end, what direction is it shooting off in either side. Is it shooting up to the left, up to the right? Is it shooting down to the left, up to the right? Or what exactly is going on? So that's what it's asking us to determine by just taking a look at the equation. Now, you have to pay attention to two things. Is it positive? Is it negative? So that's if it's positive, that's when A is greater than 0. If it's negative, A is less than 0. Our function is positive, so we're going to be taking a look at this top row over here. The second thing you need to pay attention to the degree, your highest power. Is that an even number or an odd number? If it's an even number, we're going to look at this, first row, first column when n is even and a is positive. Over here, this would be if our exponent is an odd number and it's positive. Otherwise, taking a look at this little graph, it tells us the end behavior of our graph. Ours is positive raised to an even power. That means we are looking at this little square here, which means the end behavior of our graph looks like this. To the left, it rises to the left. It's going to shoot up on the left-hand side. It's also going to shoot up, rises to the right. It's going to shoot up on the right-hand side. If it's positive and has an even power, it's going to have this end behavior every time. If it was negative and even, it would be shooting downward on either side. So you can follow just this little chart here, compare it to your equation here, and it'll tell you every time what is your graph doing on either end.